All right, hello once again, Jeff Scott of Rankin Technical College. I've been coming at you with a series of video presentations for the Rankin Technical College AWD Application and Web Development 1111.NET Framework with Web Databases class. I'm going to start this lecture right now before going into the book, etc., by letting you know that so far for this chapter I've done 3 lectures, Part 1, Part 2, and Part 3. Somehow, Part 2, which was the one I mentioned earlier that went on for 35 minutes, was lost during production. I don't know what happened. I apologize, so there won't be a Part 2. All right? Sorry about that. The book we're using is ASP.NET MVC with Entity Framework and CSS by Lee Naylor, but I am first going through the other book, Professional ASP.NET MVC 5 by John Galloway of Microsoft and others. We are on Chapter 9, Routing, and I am coming close to the end of the chapter. We're on page 288. We've got about 10 pages to go. Inside routing, how routes generate URLs. So far, this chapter is focused mainly on how routes match incoming request URLs, which is the primary responsibility for routes. Another responsibility of the routing system is the construction of a URL that corresponds to a specific route. When generating this type of URL, a request for that generated URL should match the route that was selected to generate the URL in the first place. This allows routing to be a complete two-way system for handling both incoming and outgoing URLs. In principle, it says here, developers supply a set of route values, and the routing system uses them to select the first route that it is capable of matching the URL. All right. At its core, as mentioned here, the routing system employs a simple algorithm over a simple abstraction consisting of the route collection and route-based classes. It says first, let's take a look at how routing works with these classes. A variety of methods are used to generate URLs, but they all end up calling one of two overloads of the route collection.getVirtualPath method. All right, and they're shown on the bottom here of 288 and the top of 289. It says the first method, the one that's right here, loops through each route and asks, can you generate a URL given these parameters? This is similar to the matching logic that applies when matching routes to an incoming request. If a route answers that question, it returns a virtual path instance containing the URL as well as other information about the match. If it does not match, it returns null, and the routing system moves on to the next route in the list. So this second method, the one you see highlighted here, accepts a third argument, the route name, which is unique within a route collection. In other words, no two routes can have the same name. All right. A detailed look at URL generation, bottom half of page 289, and a couple pictures on 290 and 291. The route class provides a specific implementation of the preceding high-level algorithm. Simple case. The logic most developers encounter when routing is detailed in the following steps. Number 1, is that what they show here? Okay, let's just take a look here. The developer calls a method such as an HTML action link or URL action. That method in turn calls route collection.getVirtualPath, and it passes in a request context. That request context is a dictionary of values and an optional route name used to select the correct route to generate the URI. URL. Number 2, routing looks at the route or at the required route parameters of the route and makes sure that a value exists in the supplied dictionary of route values for each required parameter. Number 3, some routes may contain default values that do not have a corresponding route parameter. Number 4, routing then applies the route constraints, if any, for each constraint. All right, and that's kind of what's shown here. The route is a match in step 5. Now the URL is generated by looking at each route parameter and then attempting to fill it with a corresponding value from the supplied dictionary. Again, take a look at what's going on here. See if you can ferret your way through here. This is a flow chart. Come in. Does it have it? As long as it's yes, it keeps going along its way here. All right. If it's no, then there's something that has to happen, or you skip a step or whatever. All right. If the route has constraints, you go on and you check those, and that's what this one is about here. Ambient route values, bottom of page 291 and going on to page 292 and 293. It says in some scenarios, URL generation makes use of values that were not explicitly supplied to the get virtual path method by the caller. Here's the scenario. Suppose you want to display a large list of tasks. Rather than dumping them all on the page at the same time, you might want to allow users to page through them via links. All right. For example, figure 9.4 shows a simple interface for doing this. There they are. Table 9.6 shows the route data for the request. To generate the URL for the next page, you only need to specify route data that will change in the new request. Even though the action link supplied only the page parameter, the routing system used the ambient route data for the controller and action. So in other words, it's smart enough to only look at what's changed. And it uses that based on what you already have, and it just incorporates the changes in. So these ambient values are the current values for those parameters within the route data for the current request. Explicitly supplied values for the controller and action, of course, override these ambient values. All right. Overflow parameters here on page 293. They're route values used in URL generation that are not specified in the route's definition. In other words, values in the route's URL, its default dictionary, and its constraints dictionary. Ambient values are never used as overflow parameters. They're used in route, the ones used in route generation are appended to the generated URL as query string parameters. You've seen this kind of thing before. More examples of URL generation with the route class, bottom of page 293 and going on to 294. It says, assume the following route has been defined. Here are some results of some URL .route URL calls that take the format that's shown there. The associated parameters and how you'd set that up is shown right here. All right, the last section pretty much of this chapter starts with inside routing, how routes tie your URL to an action. We've got about 4 or 5 pages to go. This section provides a peek under the hood to get a detailed understanding of how URLs and action methods are tied together. One common misconception is that routing is just a feature of ASP.NET MVC. Not true. All right. Routing is useful in its own right beyond just MVC. So in other words, it's used in other facets of ASP.NET. The high-level request routing pipeline on 294 and 295 says here it consists of the following high-level steps when a request is handled by ASP.NET. Number 1, the URL Routing module attempts to match the current request with the routes registered in the route table. Number 2, if one of the routes in the route table matches, the routing module grabs the iRoute handler interface from that route. Number 3, the routing module calls the getHTTP handler method of the iRoute handler, which returns the iHTTP handler that will be used to process the request. Number 4, process request is called on the HTTP handler, thus handing off the request to be handled. Number 5, in the case of ASP.NET MVC, the iRoute handler is an instance of MVC route handler, which in turn returns an MVC handler that implements iHTTP handler. It is responsible for instantiating the controller, which in turn calls the action method onSetController. Let's jump down to custom route constraints on the bottom of 295 and going on to 296. The route constraints section earlier in this chapter covered how to use regular expressions to provide fine-grained control. So we looked at that already. All right. When routing evaluates route constraints and a constraint value implements iRoute constraint, it causes the routing engine to call iRoute constraint.match. Route constraints are run for both incoming URLs and while generating URLs. Routing itself provides one implementation of this interface in the form of HTTP method constraint class. MVC also provides a number of custom constraints in the system.web.mvc.routing.constraints namespace, shown a little bit down here. Finally, using routing with web forms. Although the main focus of this book is on ASP.NET Model View Controller, routing is also a core feature of ASP.NET, which we've talked about. So it can be used with web forms, and they show some examples on here. All right, so very short little summary. Notice, if you take the crux of what they say here, routing takes a lifetime to master. Maybe not a lifetime, but at least a few days. No, when you're first learning this stuff, the best way to learn it is to just sit there and walk through the examples. I tried to do that in this chapter, and I guess you can determine whether or not I've succeeded. Again, that's it for Chapter 9. As mentioned, I'm skipping Chapter 10 on NuGet. I'm skipping Chapter 11 on ASP.NET Web API. I am skipping Chapter 12 on a single-page application with AngularJS. I am skipping Chapter 13 on dependency injection. When I come back, I'm going to go into Chapter 14, which is on unit testing. I'll see you with that soon.